Hello. Welcome to, I have to double check the title, Options for Proactively Managing Stats in SQL Server. My name is Erin Stellato. I used to be, for 9 years, a consultant. That changed about 6 weeks ago. I now work for Microsoft. I'm a program manager. But I am here as a consultant, essentially, who has dealt with environments for not really 9 years, actually for about 20 years. I'm not the PM for statistics, for anything like that, right? So this is all based on my experience in the field. This is the abstract. We don't have time for me to read that to you. I assume that you've already read it. This is important to know, right? I'm not going to give you the answer because I can't, because what the answer depends on is really your solution. So I'm going to share steps to find that solution, but in the end, this is basically going to be homework for you to do to figure out what's best for you. How we typically, traditionally manage statistics. One way, which is like the 1-star rating, is to let SQL Server do it, which means we're just letting auto-update stats run. Maybe we use a maintenance plan, which is a little bit better because we have something scheduled. I'm assuming that if you have a maintenance plan, you have something scheduled that will work. The thing about this is that it's really a sledgehammer approach because you don't have a ton of options for tweaking when it comes to the maintenance plan. But if you aren't a full-time DBA, if you're an admin, or if you're a dev, or you're not a 24/7 system, maintenance plan is fine. I don't care if it's a sledgehammer approach. If your system can handle it in terms of not blocking and stuff like that, I'm glad to have them updated. But I'm going to guess that a lot of folks have systems that are a little bit more complicated. So you've likely set up a scheduled job that runs on a regular basis, that updates statistics. Potentially it also does something related to indexes, reorg, rebuild, but I'm not going to talk about that today. I'm really focusing just on statistics. So the scheduled job is really the right way to go, as long as you are not using SP_update stats. It's a very old procedure. I do not like it. I do not recommend it. The other thing you probably do, or the thing that you hopefully do, is you use Ola Hallengren's script. I say Ola like everybody knows who he is. If you don't, he's this lovely gentleman from, I believe it's Finland, and he is a data platform MVP, and he has this solution script for maintenance. That includes index fragmentation, rebuilds, statistics. So by default, with Ola's script, there is this @updateStatistics parameter, which is null by default, and you can change to do all stats, index, or column stats. But here's what's important. It is null by default. So if you just run Ola's script and you create the maintenance plan job, it creates this, right? Execute index optimize, databases, log to table, which is equivalent to this. Notice that my update statistics, because it's the default, is null. So if this is what you're running on the left, and you think that that's updating stats for you, it's not. What you need to do is you need to have an additional option. So one that's there is only modified stats, which I don't like this one either, because it updates only if one row has changed. So if I have a table with 100 million rows and one has changed, it's going to update statistics. This is a waste of time and resources. So I don't like that option either. There's another one that's better, which is statistics modification level, where we specify a percentage of data to change, or it will use a dynamic threshold. I like that option. There's also this statistics sample option, where you can say, I want to sample with a full scan. A little bit beyond the scope of what I want to talk about today, but you have that additionally in case you need a full scan for your indexes. So the old way that I used to update stats with Ola's script is on the left, where I used the only modified statistics equals yes. And then a few years ago, he added the option on the right, which was the statistics modification level. So if you're using something like this, you're off to a good start, right? Because you're managing your fragmentation, again, separate discussion, but you're also making sure that stats get updated. And notice that I have at update statistics all here. So we're getting column and index level stats. Great. But one script typically isn't enough for a lot of the customers that I work with, because the data size is really, really large, or it's all over the place, constantly changing, constantly growing. There's data skew in the system, and there's a ton of volatility. Volatility, data's changing in some tables nonstop. So one size doesn't necessarily fit all when these factors come into play. So what I do to figure out how I'm going to manage this with multiple jobs is I use this script right here. Hopefully you all can see this well. And if you notice what I'm doing, what's important down here is my from clause. I'm joining to sysstats, sysobjects, sysschemas, and then DMDB stats properties. That thing is golden, that DMV. Because I don't have to I don't have to do a DBCC show statistics to look at the header. I can pull what I need from DB stats properties, which gives me rows in the table, last updated, modifications. So this script right here, this query, I put this into an agent job. And this isn't a very good example here. Let me go against wide world importers. I put that script into an agent job, and it runs every day at a minimum, maybe every 4 hours at most, and it pushes this information into a table so that I can start to understand my tables, how much data's in them, and how volatile they are. So what this looks like after I've set that up and started pushing data into the table is I look at this 3 ways. First, I look to see what was most recently updated. So I'm just pulling from this history table for yesterday's capture date, and I'm ordering by when things were last updated. And I'm paring this down on purpose because we really just need to look at this information. And I can see that I've got, just so you know here, by the way, this is a system with about 3,500 stats, which isn't a ton. But here we can see that we've got a fair number of stats that were updated yesterday. And then some that were updated the day before, and we go back to the 7th. And what I tend to find as I scroll through this is that there's kind of a cutoff, which is maybe the last 10 days, right? We hit the 28th, the 24th, and then we're really kind of going back in time. So I can see that there's a subset of tables that have updated within the last 10 days. So that tells me, okay, those are, probably kind of active table. There's a start. Then I'm interested in size of the tables. So let me figure out which ones are my largest. And I can say, okay, this one is one of my behemoths, right? This is, that's 14 billion rows in this table. And I've got a lot. Wouldn't it be nice if we had columns in here, or commas in here, so that I could see for sure? 1.1 billion over here. And then like 802 million, 600 and some million. And we go down. And what I tend to find, this is consistent across environments, is that I have a set of really large tables, right? In the million row. And then somewhere in here, it starts to drop off. So now we're at what is this? 97 million. And then it will go down. And so I find a threshold, I find a point where I say, okay, these 10 or 15 tables, these are my biggest tables. These are my behemoths. And I'm gonna manage those one way. Because updating stats for those tables, if there's that many rows in there, I'm not gonna full scan, because a full scan on that still only gives me 200 steps in the histogram. Not worth the time, right? Billions of rows, 200 steps, not worth the time. But I do run the update because sometimes there's an ascending key or there's something that's always increasing, and I want to make sure that the optimizer knows what that latest value is. So I want a job for those, but it may not run that often, and it's going to run with the default sample, and believe it or not, that can run really, really quick. My next set of data that I care about are the ones that are really volatile. So here I'm going to order by row modifications descending. And I'm looking to see, okay, how much data in these tables has changed since the last update to stats. And it's a fair bit. And this, I don't look at one time. I'm going to trend that over a few captures, right? Because I'm going to see, was there an update and then were there more changes? Was there an update to stats and then more changes? So I want to understand what are my busiest, most active volatile tables. And those I'm going to push to a separate job as well. And then anything that's left goes into a third job. So what this looks like is I have one script which does an update for my large tables. And again, this might run once a week, it might run every other week. It's not necessarily going to run every day. But this runs for my largest tables in the system. I'm going to update stats. I do set a modification level here, and that handles that set of tables. What's important to notice here is that I have my fragmentation options set to null. So we're not doing anything related to reorg rebuild here. I'm not touching that. That I'm going to manage separately if I need to. I'm more concerned about updating stats in this type of scenario. So we set those to null. It's not going to touch rebuild reorg. It's just going to update stats. Then I have another job for my volatile tables. Same thing. Not touching reorg rebuild. I don't care. But I am going to hit those busy tables. And here, one of the things I might do is I might say only modified stats, yes. Even though I told you I didn't like that, I know that these are busy tables. So I'm going to expect that they're worth updating regularly. And that job I schedule maybe every day, maybe multiple times per day, right? I have had systems where I've had that job run every hour for the volatile tables because those volatile tables are not usually ginormous, right? And that can handle running frequently. And I'm still not updating these with a full scan. And the default sample very often is fine. It's most often can be good enough. And then my third job is everything else. So in this previous job, I was specifying exactly what what objects I wanted to update. In this everything else, I have this dash in front of there. I just want to make sure that you can see that. I have the dash because I'm excluding it. So this job excludes the large tables, excludes the volatile tables, and still is just updating statistics. So I have 3 jobs at a minimum. You may find you need more, but the idea here is that this gives you an idea of how to start. Separate out your behemoths, run those one way. Find your volatile tables, run those another way. Then take everything else and run that in a third job. And if they have different schedules, that's fine. This one, if I remember correctly, ran, I think, once a week. The volatile one ran every 4 hours in one of the environments. And then the big tables, it ran every other week, I think, something like that. And that was a 24/7, 20 terabyte system, and that worked for them for stats. And I've implemented that again at other customers. The one thing that you then have to think about that I haven't addressed is Skew. So this is just the code for the job. Sorry, I want to show that really quick. So reminder, fragmentation set to null. I can either do only modified stats for the volatile tables, or I can do stats modification level for the other 2. And then in terms of Skew, this is a tricky one, right? The default sample for stats is typically good enough. But if I suspect there's Skew, then I would pull those tables into the 4th job that I might update with a full scan. Or, depending on the size of the table, I might create filtered statistics on that and make sure that that gets updated with the job as well. So Kimberly Tripp, what used to be my boss over at SQLskills, has code to analyze this. It's already out there. She actually did a session at the past summit several years ago where she spends a solid hour talking about this challenge and this code that she developed that you can use to analyze individual columns. You can do this for columns in tables. You can do this for the whole database to help you identify what tables, what columns have skew so that you may need to manage differently. All right? And if you do need to manage those differently and you're going to sample them, my general recommendation is sample with the full scan. I've had folks say, what about a 30% or 50% or 75%? In my testing, above 25%, like doing a 50 or 75% sample, it costs just as much in terms of resources as a full scan. So do the full scan, okay? And if the full scan doesn't give the optimizer enough information about your distribution of data, then you've got to go to filtered statistics, which is what her code can help you figure out and also create. I couldn't get into that today, but again, the point was to give you the tools that you need for where to go next. So I'm going to see if I have any questions. None. Yes?
What about large and volatile?
What about large and volatile? Define large.
The behemoths.
The behemoths and they're volatile. Are they only being added to, or are you telling me that they're being added to and deleted from? Or are you telling me that they're being added to, deleted from, and updated? Or are you telling me that they're just being updated? They're just being added to.
Updated.
They're just being updated. Okay. In that scenario, this is a really good question. So in a case where I've got something really, really large, and it is only being updated, but there's lots and lots of updates to it, I would handle that slightly different as well. I would pull those out into another job, and I would specifically focus on either the stats for the indexes or the stats for the columns that are most heavily queried in terms of a predicate or a join, right? So if you have a table that's 100 columns wide, depending upon what kind of queries folks write, you could be all over the place in terms of all the stats you have created. In that case, you need to drill down into the most important stats because it's larger, because you're going to run that update frequently, and it's a larger table. So don't do every single stat on there. You have to identify the ones that are most important. Programmatically, you should still be able to do that with the code that I gave you because you're going to look for modified, right? What's being modified the most, and rather than just taking the whole table, pull the stats that are most relevant. Does that make sense? Okay. Don't be afraid to create multiple jobs for your stats. The tricky part is keeping track of which objects are where, right? Documentation is important, but you can totally have multiple jobs to manage all these different objects rather than trying to do it with one. Are we good? No questions online? Okay. Any other questions? Yes? Oh, great question. So what about tables that only behave well with a full scan? So in that case, I still love leaving auto update stats on for my database because it's just a safety net in my opinion. I really want all of my jobs to really manage stats, but I am not perfect, right? And if you have multiple folks in the environment, you can miss something. So I leave auto update enabled. But then when I have to have the full scan, and I always want the full scan, then I make sure I've persist sample. Have you seen that option? So there's an option for statistics, which is a persist sample %, which you can specify. And even if it gets auto updated, it will still use the same sample rate. But you could also do a no recompute on that, which would mean then don't automatic update. So you have two options for how you want to do that. If you really want to control it, then I would say a no recompute, and it's only going to get updated with the job with a full scan. Yeah, you're totally fine. You're totally fine. You have two options for how you handle that. All right. Yes? Yes? So the question is, I have auto update enabled. Could I also enable auto update async? Should I update auto update, or should I enable auto update async? What do you think my answer is? What was it? It depends, right? It depends upon your solution. My friend Glenn Berry, who I used to work with at SQLskills, Glenn always recommend enabling auto update async. I think it's important to understand what that option does and the ramifications of that, and then decide if you want to enable it. So I don't have a straight answer for you there, and always. I want you to make sure you understand what it does and then decide. All right. If you have any more questions, feel free to come up, but we're at time. Thank you for attending today. Appreciate it. Oh, reminder to provide feedback. I forget to do this every single time. But you can do it online. There's a QR card up there. There's a QR code. There's an ID. And if you have questions, come on up. Send me an email.